Hello everyone. Today we will have a look at principal stresses. Principal stresses means nothing but the stress gets transformed. Look, if this is a beam or say a member, then this load is applied on this member, and if we consider a section like this, then this load will get transformed on this section like this. This means that if we draw the section, then there are two components. One component is normal component and other component is tangential. This normal component induces normal stress, while the tangential component induces tangential or shear stress. Now, tangential means parallel, and any force which is parallel is called as shear force. So whenever there is tangential force or parallel force, then it is called as shear force. Example, if this is a plane and this is a force on this plane acting like this, then S will be called as shear because this is parallel. Now we will come to our point that this is the condition. Say we'll take it here out. Look, this is our beam, and this beam is subjected to load P. Now I am saying that if the load is subjected like this is P, then this will be a normal stress component and this will be a shear stress component. Now we can analyze these stresses by the help of Mohr's circle. Look, this P load will get transformed. This P load gets transformed into a normal component and a shear component. Now consider this is a plane and this is a plane. These are two planes. Now this plane is subjected to a load like this. This plane is subjected to a load like this. This plane consists of a normal as well as shear component, and this plane consists of normal component only. Now in the second case, the deformation of plane AB will be only due to normal stress, but here the deformation is due to normal and shear component. Here the deformation means in case 2 the deformation is due to normal component only, that is this is the principal one. What do you mean by principal? By the word principal we mean only governing agent. Okay, so this is the only governing agent. That means sigma n will be called as principal stress. Thus we can conclude that when we call the normal stress as principal stress, when we call normal stress as principal stress, when it is the only normal stress that is free of shear. So if a plane is free of shear, it is called a principal plane, and the stress on that plane is called as principal stress. Okay, so this is simple. This was just a definition of principal stress. Now principal stress will be like, let this will be a stress, this will be a stress sigma x, and this will be a stress sigma y. Now if sigma x is greater than sigma y, then this will be the major principal stress, and this will be called as minor principal stress. So this is simple. Now we said that on this plane AB there was only normal stress component, and this was the only governing stress. This was the only governing stress as far as the deformation is concerned. Now same manner, if we consider plane PQ, then there is a shear component and a normal component. So the deformation is due to normal stress as well as shear stress. In such a case, the plane is known as normal plane, and therefore sigma n is normal stress only. Thus on a normal plane there are normal stresses and shear stresses, but on a principal plane there is only normal stress and normal stress, nothing else. Okay, so in case of a normal plane there are shear as well as normal stresses, while in case of principal plane there are normal stresses only. Now we can analyze the principal stresses, analysis of principal stresses by Mohr's circle method. Now what is Mohr's circle? Mohr's circle is a plot of shear stress here and normal stress here. It means that Mohr's circle is simply normal stress versus shear stress. Normal stress on abscissa and on shear stress on ordinate, that is x-axis and y-axis respectively. Now how can we draw the Mohr's circle? I will just tell you the procedure, okay, because this is most important. Now consider this element. So this will be a shear component tau xy, and let there be a normal stress condition like this. So this will be sigma x, this will be sigma y. Okay, now we can plot the Mohr's circle for this case. Okay, we can plot the Mohr's circle for this case. So I will just draw the Mohr's circle. The Mohr's circle will be, okay, now okay, say okay, now let consider, first of all we have to decide the parameters which are positive and which are negative. Look, the clockwise shear of this manner will be positive, while the anti-clockwise shear will be negative. Simple. Then positive means tensile normal stress will be positive, and compressive normal stress will be negative. Now consider that we have to plot these normal and shear components here, and we have to plot the Mohr circle. So now I would just take one by one. First of all, I will plot the normal stresses. So let sigma x be greater than sigma y. Now if sigma x is greater, somewhere it will be here, sigma x. Okay, this will be sigma x, and somewhere there will be sigma y, because both are positive. Now sigma x, on the plane of sigma x there is a shear component, then the shear component is negative, so let this be a shear component. Okay, and this will be the sigma x tau xy coordinate. In similar manner, here will be a sigma y tau xy component. Now what we have to do is to join both these points, means we can join points A, B. So if we join points A, B, then we get a point C, which is the center of the Mohr circle. So considering CB as the radius, considering CB as the radius, we can just draw the Mohr circle like this. Okay, so considering CB as the radius, we can draw the Mohr circle, and we know CB and AC will be same, so we can just draw the Mohr circle like this. So considering CB and AB as the radius, we'll just draw a Mohr circle like this. Now we know that this C will be center of Mohr circle, so C will be center of Mohr circle. Okay, then CB will be radius of Mohr circle. Then we can derive the conclusions. Now further, look, this C is the center of Mohr circle. Now the maximum limit will be this one. Okay, this means this is maximum. This is a shear axis. This will be tau, and this will be tau max. Okay, so this is simply tau max. Now this value is tau max, and as we go here shear goes on decreasing, and here tau is equal to 0. Similarly here tau is equal to 0, but there is some value of the normal stress. So at this point shear is 0, but there is some value of the normal stress. Here also shear is 0, but there is some value of the normal stress. Now this value is greater and this value is smaller, so we call it as major principal stress, and this is called as minor principal stress. Okay, so simply the points P and Q denote principal stresses. Okay, principal stresses. Now we can find tau max. Tau max is equal to what? Tau max is the radius of Mohr's circle. Yes, we can look here that we can find over here that this point is tau max, and this is also the radius of Mohr circle. Okay, so if that is the radius of Mohr circle, we can simply find radius of Mohr circle. Radius of Mohr circle means the distance CQ, or say the distance CP. Okay, so if the radius of Mohr circle, then this is simply what? Diameter of circle divided by 2. And what is the diameter of circle? This is the diameter of circle, means PQ. So if PQ is the diameter of circle, then PQ means what? PQ means sigma 1 minus sigma 2. So we can write PQ as, PQ can be written as PQ by 2. It will be sigma 1 minus sigma 2 divided by 2. So this will be tau max. Okay, this is very simple. Okay, that's it. For more videos, stay tuned with Mace. You can also join the Telegram channel at the rate Mace Dhule. Okay, goodbye.